Okay, so we're going to do this race again. Daniel has identified that although he's wearing boots today, so he's going to be a slower runner, and Stuart's been identified as a very fast runner. So we're going to see if we put someone on the curved side that is faster than someone slower on the straight side, can we get them to meet at the end point at the same point? Ready? On your marks, get set, go. Yay! So they arrived at the same time. So we have just proven with the help of Daniel and Stuart that it is possible for the person on the flat side and the person on the curved side to arrive at the same time. Someone put up their hand, please, and tell us what has to happen so that the person on the curved side arrives at the same time as the person on the flat side. What has to be true? Hannah?
They have to be faster.
Right, the person on the curved side must be faster. And what are they making up for? If they run faster, they can arrive at the same time. What are they making up for with their extra fast running? Miles?
They're making up for the fact that they have to run a little bit more because of the curve.
Exactly. They're making up for the fact that because of the curve, they need to run faster to make up for the fact that the curve is a longer distance. This is exactly what happens with air going under a wing and air going over a wing. The air under the wing goes as fast as it can and goes from the beginning of the wing to the end, or from the back of the wing, or no, the front of the wing to the back of the wing on the bottom side. The air that goes over the top is forced to go faster because this is the thing, boys and girls. When the air splits up at this point here, when the air splits up at the beginning, the law of physics tells us that the air molecules will reach the end point at the same time. It is a physical impossibility for them to not arrive at the same time because air is fluid, like water. If we poured water over a shape like this, the top water and the bottom water would land at the end point at the same time. But the water or the air going over the curve would naturally speed up in order to arrive at the end at the same time as the bottom air or water.
How's this speed?
Okay, so Cameron, what did you just say? Because it was perfect.
I want to test it with water.
Okay, Cameron thinks that we should test it with water, and that will be our next step for inquiry. Thanks, Cam.
Thank you.